Good afternoon, everybody. Today's lecture is going to demonstrate Newton's second law of motion. So for the first part, we are going to keep the cart's mass constant, and first a force of 10 newtons will be applied to the cart, and you have the acceleration putting it up to some speed. Now let's increase this force to 20 newtons. You can see the acceleration is larger, making the speed go up to a greater speed. And then finally, a 30 Newton force will be applied, and you can see the acceleration is the greatest, and it got the greatest speed due to the acceleration. So for the first part of this demonstration, we can see that the acceleration that an object undergoes is directly proportional to the net force applied to it. Now for the second part of the demonstration, a constant force of 30 newtons will be applied and the mass will be changed. So now we'll put the 30 newtons of force so it speeds up to that speed due to its large acceleration. Now I will place one mass in here, put the 30 newtons of force again. You can see when the mass increased, the acceleration decreased. So there was a smaller acceleration to speed it up to a lower speed. Now two masses are put on this cart, 30 newtons applied again. You can see the acceleration is even smaller yet. And finally I'll put three masses on top of the cart, put the 30 newtons again. You can see the acceleration is the smallest in that case. So we can see that as the mass is increased, the acceleration decreases. Therefore, the acceleration is inversely proportional to the mass. So the second conclusion we can draw is acceleration of an object is inversely proportional to its mass. So therefore we get the combined proportion that states that the acceleration that an object undergoes is directly proportional to the net force applied to it and inversely proportional to its mass. That is Newton's second law of motion, and you can see the equation form acceleration is equal to the net force divided by the mass.